I would like to invite Dr. Yousaf Zafar as our keynote speaker. Dr. Yousaf is ICAC Best Scientist Award holder of 2012. He served as Chairman Pakistan Agricultural Research Council from 2016 to 2019. Dr. Yousaf has over 40 years experience in natural sciences. He obtained PhD degree in 1986 and joined Pakistan Atomic Energy Commission in 1979. Dr. Yousaf has 3 postdoctoral degrees from USA and 1 from Italy. He is among the founders of National Institute of Biotechnology and Genetic Engineering, NIBG, and National Institute of Genetics and Advanced Biotechnology, NAGAB. He established cotton biotechnology in NIBG and developed several genetically modified crops. He mentored 15 PhD students, 86 MPhil students, and published over 200 research articles and several book chapters. Dr. Yousaf acted in high-profile positions, including Director General, Pakistan Atomic Energy Commission. Pakistan Atomic Energy Commission awarded him Best Scientist Award in year 2000. His services were recognized by Government of Pakistan, and he was awarded with Medal of Distinction, Tamgha-e-Imtiaz, in 2004. Dr. Yousaf is USDA Cochrane Fellow and presently Director at Board of Pakistan Mercantile Exchange. Over to you, Dr. Yousaf.
The topic given to me was microbial technologies from bench to business, and what are the challenges and opportunities in Pakistan. I specifically, with working for over 40 years in microbiology and biological sciences and as well as biotechnology, I thought I must share my thoughts that why
group mein
I will request others to mute their microphone, please.
1:30 से 1:45 बजे तक
Please, everybody mute your mic.
इसमें ये लोग
Please mute your mics. I will be talking on, first general introduction regarding this webinar, and then what is happening in 3 sectors. As you know, for any science and technology development in a country, there are 3 major sections. One is the academics, second is services, and the last one is the product development. So what Pakistan did in microbiology and attached to this biotechnology, because we know biotechnology major area which contributes towards the development of biotechnology is microbiology, attached with this molecular biology and chemical engineering. And what are the hiccups or problems in academia and industry relationships, why there is a trust deficit, and why Pakistan could not perform to a level which is required for a developing country. What are the present national scenario and challenges, and what is the way forward? So I will be talking on this step by step. We all know that this era is a knowledge era. You normally listen to the K economy, and all the time Professor Ataur Rahman and others, who was yesterday in Faisalabad and as a chief guest of a National Microbiology Conference at DC University, Faisalabad, he also emphasized that and given the example of Singapore, that despite they are not growing a single grain of rice or wheat or corn, they are the top 11 economies, and that is based on the knowledge economy. The National University Singapore is holding so many patents, even on cotton coloring and printing, and on liver transplants and other things. So therefore, they develop a system that the economy, is the economic engine is the knowledge, the skilled people, the patent, the processes which they develop, and then they sell out, to rest of the world. So this century is the 21st century is rightly called the bio century, because the tremendous development was going on in the field of microbiology in terms of the stem cell, the sequencing techniques, the understanding of the life processes. So it is we have seen recently that how in a short time the corona vaccine was developed by so many companies. There were more than 70 companies who were working hard to develop the vaccine, and 7 or 8 companies were able to develop and put it in the market within a year, and able to put half of the population of this world was already vaccinated in such a short period of time. So this is a tremendous success of the knowledge economy in the globally. So what Pakistan recognized that without the human resource, you cannot, make a development. So if you see in early 80s, we have only 28 or 30 universities all over Pakistan. The very low number. Only 2 private universities, Aga Khan and Hamdard University. There were only 2 who, private sector universities. All were the public sector universities. But after 1990s, in fact, the late 90s, we have a proliferation of public sector universities and also the private universities, particularly in the management sciences, engineering, and medical sciences. They developed a large number of private universities. On 6th September this year, I mean, 3 months ago, the HEC has published the recognized university list. And according to that, we have 232, higher education institutions or degree awarding institutes, 232, in this country. Out of this, 141 are the public sector and the private sector are 91. And we also know that this is some remarkable figure that in Islamabad, which is a very small, Islamabad capital territory, they have 25 universities which are recognized by HEC, while the Balochistan, which is a huge province, it's only 10 universities, So there is a lot of imbalance also, in the country. And Punjab is the largest because the population is largest, but Sindh is also have a 67 universities. So these universities, the HEC made, a lot of investment to establish the higher learning institutes. And in terms of quantity, the Pakistan is on a higher trajectory. And with this, making certain rules, there was also a spontaneous burst of a huge number of publications in lower and middle order journals. So the Pakistan rating in the global system also enhanced tremendously due to the establishment of the higher number of institutions. Relating to microbiology, the degree awarding till late 1970s, till mid 1970s, we have only one place, that is called Karachi University, who has a BS and MS program on microbiology, exclusively on microbiology. And there was one Jinnah Postgraduate Medical Institute also in Karachi who was awarding MPhil degree to the MBBS or MD doctors on microbiology, which is the medical microbiology. So since the beginning of this inception of Pakistan, 1947 till 1970, I mean 20-25 years, we have only one institution, Karachi University Microbial, is a pioneer. And their graduates, they were spread all over the world. And some was, like in Cold Spring Harbor or Charles Kettering Lab, they earned a big name. And if you go to US or UK, you will find the alumni of Karachi University in a very large number. But now, this year, according to HEC, we have 42 departments in the country who are awarding BS microbiology and above. That means MS and PhD degrees in the national institutions. So you can see the development that in the last, 50 years, we have developed more than 42 departments of microbiology. And surprising to me the KP, has the highest number of microbiology departments. The 12 universities who claim that they are, especially in Haripur University and Ahmedabad University at Havenia and others, even they have the microbiology department. HEC has also developed curriculum for BS, MS, and PhD. They have a certain guidelines that any person who is getting microbiology degree must have studied some fundamental course, some optional courses, and the boundaries of that courses were also decided. So there is a tremendous development of microbiology as far as the academics is concerned. So along with that, as we know, the microbes are the working horse for the biotechnology. And biotechnology, by definition, is the application of biological sciences, for any good or process or a system. So by definition, by default, it is an applied science. So it is multidisciplinary. That is in all over the Western countries. There is no separate biotechnology department, but you select the subject according to biotechnology like molecular biology, microbiology, immunology, and chemical engineering, physics. You get the degree of biotechnology. So it's a multidisciplinary, and it is also multi-sectoral. For example, there is a green biotechnology which deals with agriculture, red biotechnology with drugs and vaccine, white biotechnology deals with the industry, and a blue technology with the aqua or fisheries. Today, I will discuss only the relate to the microbial technologies with the pharmaceutical as well as with the industry, and will share with you that where we stand. We know that the biotechnology, has three distinct phases. In ancient biotechnology, when before the history, we know that the Egyptian civilization or this Amazon civilization or Indus civilization, they were using yeast to make the bread, leaven bread. So without knowing, they were using microbes, to ferment for fermenting processes in the bread, carbohydrates, or also in the sugar for making wines and beers. So, but there is a classical biotechnology era started with the pre-industrial era. There we see that the penicillin was discovered, say in 1928. The tissue culture technology was developed. The vaccine were developed by Louis Pasteur. Fermentation process were reached to its zenith. So this is called the classical biotechnology. In US, now it is called the backyard biotechnology. How you can make use of the microbes for making useful products. But the recent era, after the discovery of the DNA, that it is the genetic material in 1954, and then understanding the various processes of microbiology and molecular biology and RNA, DNA, protein interaction. So people developed, the genetic engineering technology, and in 1978, there is a human insulin was developed. For the first time, earlier they used to extract, pancreas from the slaughterhouse of the cows and extract that and putting into the human. So there was a lot of reactions. It was expensive. Shelf life was limited. But now with this recombinant human insulin, if you go even to the Bhakkar or Lia or in remote area in Balochistan, you will have this recombinant vaccine available all the time to all the people. So we have seen a tremendous progress of biotechnology linked with the fermentation and microbial technology. Right? So Pakistan, realized this thing way back in 1981. We invited, some of the good microbiologists like Dr. Bukhari, who was an alumni of Karachi, and he was in Charles. This was Cold Spring Harbor Lab. He was working with Professor Watson, who discovered DNA, and was the director of the Cold Spring Harbor. And he spent about 2 weeks in Faisalabad, and USNSF, and they introduced two Nobel laureates came there, and 19 Roberts, who later formed the company of restriction enzymes. So he was also in Pakistan, in Faisalabad. And he organized a course, and in that course, they met at that time the President Ziaul Haq, and insisted that Pakistan should, develop biotechnology field, because unlike IT, where we left behind and India make a lot of progress, this is a start of biotechnology and Pakistan can share. So in Lahore, Center of Excellence in Molecular Biology was developed in 1984. Then our PC-1 was approved and NIPG was formed. And today, as per the recent data, there was more than 45 institute or centers or departments which claim that they are working on the biotechnology, and mostly on agriculture side or a plant side. But every these 45 center, whether they're working on animal biotechnology or they are working with the microbes and they are working on the microbial systems also. So if you see in 90s, we have only one center that it can, but if you see in 2019 or this year, we have 53 institutes who are awarding biotechnology degree in the country. Mostly this is plant biotechnology, as I told you, is the dominant one, while the modern one, they are 12, and animal biotechnology is recently developing, it is still in infancy. And we know out of these 53, it is in the 232 universities which are present in the country. So coming to the second part of that, how we can go from bench to business. If mere getting the degree or imparting education is not enough, it must bring the socio-economic change in the country. It resolves the problems which a country citizen faces. So the science, technology, innovation should contribute to the country's development. And this is a very complex system presently in the present world. So people call that L2L, I mean lab to land, or F2F, farm to fork, or bench to bed. That how you develop the pharmaceutical, how you process a food, how you have a GM thing going to the processing system. So for this, we must have a policy framework. So the political will is the most important, thing that which can develop a sector in a country. So you must have an infrastructure accordingly. That means the facilities, in terms of instrumentation, the human resource, and the funding. These three, financial, human, and the civil work, and the instruments, equipment, they should supply of electricity and the clean water, the chemical, especially the precious chemical. This is also very, very important, contribute towards the development of a business model in a country. So, and then, technology development is not easy, that how you link in the industry with the academia. So, and now in the global situation, you have regulatory issues of the biosafety, intellectual property rights, plant breeder rights, the patents, and the restriction of transfer of technology. So they are many more things become really complex, and then you must have a acceptance from public. They must accept, for example, the GMO become debatable, or anything relate to the halal or haram, or whether the synthetic product is acceptable to the public. So a communication by scientists in a easier manner is also just like this webinar is one example where you convey some of the thoughts to the general public. And then government has a lot of responsibility, that how the product like probiotic which Chakra is working on in Nigab, how it will reach reach to the livestock sector. So you must have a bankable feasibility, you must availability of venture capital, because out of 100 ventures, two or three get success, all other fail. So you must have venture capital. People are ready to invest to a new product, and the government policy should be the conducive, and there must be a science technology parks. Like our neighbor Iran, they have 35 parks. China has hundreds of parks in every province of the country, where you have an enabling environment for for developing certain things. Then the government should have a stewardship of the technology. That means you ban the import so that the local developed product should get space, because in the initial phase it will be must be expensive because of the volume, and because China is making large volume. So we see so many factories of closed because the China product is cheaper than the which you make domestically. But if you want to develop S&T business, based business, then you must have some policies which were free tax incentives and ban the import or put more duties on import, and you facilitate the export. So how things have changed, before 1986, you could not patent the diaphragms. That was a big change, as a microbiologist, as a biotechnologist, as a biologist, we must understand that how paradigm shift has taken place. It was Anand Chakrabarti from University of Ohio. He developed a microbe and made genetically engineered for the bioremediation or, for the spill of oil, so he developed a microbe which we can, eat or have a property of cleaning the polluted oil soils. And he went to the US patent office for getting, as a patent. So that was refused. He went to US Supreme Court, and Diamond was took away the case, and then historic decision made by US Supreme Court in 1986 and approved the principle of patenting genetically engineered life forms. And that made the big change, the transfer of technology, the restriction of using any other micro without approval or without giving the fee, it was banned. So there was a lot of restriction was made and compelling the nations to develop their own system. And then, globally, the other change came with the WTO. People don't understand that the SPS and intellectual property rights, Pakistan was among the first 34 founding members of WTO, World Trade Organization, in Switzerland. And they made restriction on, subsidies, on exports, rebates and imports bans. So they made every commodity, education, health, agriculture, they make it a tradable commodity, not for public good. So this is a paradigm shift, another shift that which we used to say, yeah, I want to serve humanity, I want to become a doctor, or I want to become a scientist. So this is the thing, everything is tradable. So agriculture, education, health, medicine, you can patent it. You have a restriction on its, infringement of laws. Similarly, WHO developed, the non-communicable disease and communicable disease systems and codex alimentarius with the FAO, a code of conduct that how much, aflatoxin should be present in a or should not be present in a certain foods and all those things. We have conference on disarmament, and after 9/11, the microbes, especially the diagnostic labs who are working with the polio or with liver cancer, this hepatitis B, C, and others. So biosafety issues came, and bioweapon, and it's become a real issue. And the US government has spent millions of dollars to develop in every country a biosafety regimes, so that the government should know how they dispense their waste, how many laboratories are there. So the all database was available, and you cannot export certain, organism without the getting license from the Ministry of Foreign Affairs. We have a disarmament office in Foreign Office, and they allow any organism which we import in the Pakistan or export, you have to get license from them. When very less people know that this is so important and made a very strong screen or filter at the government level. So if you give in a very pictorial form, this is also for a GM crop, but it is any microbial product also. So earlier we used to have a research and development and we develop a technology, and then it's going back to the economic growth and food security or improved nutrition. But now intellectual property rights are there, biosafety is there, then the industry is there, and this the intellectual property rights and all these things are are playing the role in the cycle. It has become a very complex. You must have a public outreach, industry outreach, and so it is not simple to go from B to B, bench to business, and you have to fill in all the things in order to reach to the commercial market. We are very fortunate that the Pakistan, at least with the policy level, we have all the policies, all our documents mention microbiology, biotechnology as one of the growth engine, and for the socio-economic development. Unlike many countries who banned, certain things, so Pakistan is very lucky that all our policy documents they profess that we must adapt IT or biotechnology and nanotechnology. So we made all the theory commissions in the country. So in order to fill the gap, there were many attempts were made in the past that how to link R&D with the business. So that whatever you develop on the bench in the laboratory, how it can reach to how it can be commercialized. As you know, all academic institution has now the ORIC office, Office of Research, Innovation and Commercialization. But they are struggling, but we know their success is very little, if any. So even the institutional level, PCSIR, Pakistan Atomic Commission, and PARC, they made their own private companies so that they can commercialize their product to the consumers. So they made little attempt, but in the public sector, their success was not, remarkable. Then at the program level, the different ministries, different organizations started their program. We know NHEC, they have started university industry linkage first, then ORIC offices, and now Technology Development Fund. They gave up to 40 million, and then the private sector should also equally contribute. And if any, product is able to commercialize, they were ready to this. Then Ministry of Finance, they started with US Competitive Support Fund, Ministry of IT Ignite program. In IT sector, there's a lot of development in drone technology and the use of mobile for weather reporting and for other things. So they have their programs. So there were attempts were made in the past, but as we discussed, that Pakistan is such a big country, but unfortunately we have a single, science technology park. Today, it was in 2019, December 9. I mean, 2 years before, Honorable Prime Minister, he inaugurated in the NUST, and the young, there are many entrepreneurs are there, but unfortunately they are also restricted to making biofertilizers and others who were already was done by many public and private, institutions. And today in Lahore, the Prime Minister will inaugurate another technology park in Lahore. So that will be the second one. There were a lot of announcements in all the 4 provinces, but unfortunately, none is to the level, even a single level like what we have seen in Iran or in China or in India. So we have sporadic success stories with microbial technology. In services sector, we know with our microbiologists, they are serving in diagnostic labs because the labs are becoming more very modern with PCR, with ELISA and others. So when the corona came, immediately we have able to develop laboratories all over Pakistan, and the PCR based or ELISA based test was made, amenable to all the public. So it was due to the human resource experience or skilled human resource of microbiology, molecular biology, biotechnology, which was available in the country, and they immediately took up temporary jobs, and they were also providing in the regulatory bodies like food standard agencies and in different PSQCA or Pakistan standards or PNCA. national accredited authority. So they are our microbiologists, they are serving there. In production technologies, we know that earlier all our sugar mills, except Shakarganj, were not making ethanol. We were exporting molasses, which is the byproduct of the sugar. But fortunately, our microbiologists and biotechnologists, they put a lot of emphasis. And now 20 out of 70, 75 sugar mills, 28 sugar plants, they have their ethanol production system through microbiological fermentation technology. And with this ethanol, either they are exporting or making energy out of that. So biofertilizer, this is another success story where NIPG has made the biopower first in 1996. And then, many other organizations like NARC, BioExode and others. So there are more than 20 units which are registered with PSUCA, a Pakistan standard for making biofertilizer. We are almost self-sufficient in this sector. There are few biogas units in the sugarcane industry who are generating their own gas for running the boilers. And the beverage, Murray Brewery and in Koita Brewery, they are using the fermentation technology. So these are few success stories. But at the same time, we must be ready to face. Although if you look at the publications, there are not hundreds but thousands of publications and theses that are available on cellulase, hemicellulase, amylase, lipase from various raw material and from waste material. We know that these enzymes, they are being imported at a very heavy cost of around 300 million US dollars. And our textile industry, the largest industry, it $15 billion export, and they are using amylase and hemicellulase for different processes. Paper industry, food industry, leather industry, they are all big user of industrial enzymes, and these are being produced through different microbes. Even the blue color is not being produced by for denim, for jeans, by through microbial fermentation process. But unfortunately, there are thousands of papers, thousands of our projects by HEC, by Ministry of Science and Technology, by ALP and by PSF on producing these enzymes and these materials. But unfortunately, not a single so far process was taken up by any industry in the country to a commercial level. We have, in 60s and in late 60s, we have two, antibiotic production plant, one at South Khel by WPIDC, is the public sector West Pakistan Industry Development Corporation at that time. And they were making penicillin unit was there, and Pharmagen in Lahore, close to General Hospital on Lahore Khanna Road was there. It was later on taken by private company Pharmagen. So both units are closed. This Pharmagen was sold by the GSK or Guru Bose company, Glaxo company to Pharmagen, but unable to run these fermentation. Unfortunately, these sole antibiotic production units, they are closed. Bioremediation, you see a lot of talk, a lot of research papers, a lot of theses, but so far at the commercial level, there is not a single unit which you can give an example that the bioremediation you are cleaning at a larger scale. We have put one small plant in Rose and Jasmine Garden, but it was removed next day by the CEA and it was not performing. New biopharmaceutical like interferon, like vaccines, if this is we will discuss later, and biopesticide. And the last part is the national microbial collection. We have plant collections, we have a gene bank for plants, and we have also zoological survey by Ministry of Climate Change. But unfortunately, many previous attempts failed to develop a national microbial collection. Now NIGAB and PGRI, they are trying to develop Dr. Zafar a national microbial collection. And this is the most important missing part in the development of microbial technology in the country. We have such a novel microbe, but with the exit of any scientist or his retirement, all the collection is lost. Same is the case with the genes and clones and other materials. So As I discussed earlier, I will deal with only two industries. One is the industrial sector I already discussed. The other is Pakistan pharma industry. Uh, Pakistan is very fortunate to have more than 700 manufacturing units, which fulfill the 95% requirement of domestic requirement of the country. We have 350 national pharmaceutical industry and 25 which are working under the license of the foreign, and we have also the foreign, companies like Pfizer, like other companies, the Bayer, which have a multinational base. They are making all sort of medicine, vaccine, biopharmaceuticals, and rare compounds. I will give you one example of fermentation processes where microbial things are involved and where our academia was working a lot in a big way, like CAM or NIFG or many institutions were working. For human interferon, you have listened to so many things. HEC has given 635 million rupees to CAM and also to different other institutions. But when the private sector in Pakistan gets pharma, this is Dr. Khalid who came from US and he developed this gets pharma in Karachi, and Feroz Usman Saab he developed. So both these units got the whole process, one from the UK and Amsterdam, from Holland, while Feroz got the all process from Argentina, and not from our local or domestic education institute. So there is a lot of trust deficit between the academia and industry. I picked this example to show you that despite a lot of claims, despite a lot of investment in the research institutions and research departments, so when it comes to the commercialization, so the industry trusts on the foreign, processes, and these two, they are making interferon, they are making hepatitis B vaccine in the country, but not taken process from any national or academic research center. And we also know, as I told you earlier, the open law and plants are closed. So what is the way forward? How we can make development, in this microbial sector? First of all, as I always example of the nuclear technology. If the government and political will is there, if the establishment and the political leadership, opposition, armed forces, they are all on one page, then despite sanctions, despite no foreign aid, despite no technology transfer, Pakistan made tremendous progress in nuclear technology because the political will was there. So, and everybody was on the one page, and the funds was not an issue. Human resource was developed accordingly. So if you want to develop in this modern era, the strategic security, and with this equally important are the food security, the health security, water security. So the S&D and innovation, science and technology innovation should be placed on top priority list by any government, either the military government or the civilian government. They must give a lot of top priority to this in terms of resources. So human resource development, just because the human man behind the machine is very important. So, and they must be developed in the famous international institutes. We have to develop the infrastructure in the universities because we develop the civil, work, a lot of buildings and the rooms, but they are empty. Or once they've bought one's machine and there is no funds for its repair and replacing it with the new versions. So because the technology is developing so fast, so everything become obsolete after 2 years. So we have more than 40 or 50, DNA sequencer, but most of them become obsolete. So we have to do the stewardship of the technology, and we have to develop, repositories, particularly microbial culture collection. And there is a need, the livestock biotechnology is highly neglected. Unlike, human vaccines, animal vaccines are much easier to produce because there is a less regulatory system. And we have a huge number, about 200 million, livestock in terms of small ruminants and the large animals. So there's a big scope in developing the livestock biotechnology. With this, I will again thankful. At the end, I will say that I'm grateful to the organizer for the seminar. I always quote this thing. This is Abdul Sattar Idi, one Tamina Durrani who wrote a book on him. She asked him that if you say in one sentence what is the bottom line or punch line of your life, what is the take home message? So he narrated a small incident that when he was young, he was going with his father to mosque for a birthday celebration of Prophet Muhammad. And after distribution of the sweets, people used to throw the envelope all in the courtyard of the mosque, and people complain, oh, they make it dirty. He said, I just asked my father to allow me, and he said he took only 5 to 10 minutes to gather all the used envelope, and I threw them in a bin, and the mosque was again, the courtyard was again clean. So he said, my take home message for everybody is that the work is accomplished by doing it and not by talking about it. Unfortunately, our nation, involved mostly in talking, and we are not practically doing things, and I selected this slide particularly in the microbial technology field because since inception, we are listening, that we will do this thing, we can do this thing, but in practical terms, I have shown you the fermentation technology or bioremediation or bioprocessing or except few success stories. We have, lot of things to do. We are doing very good in academics. We are doing very good in services, in diagnostics and other things. But, in terms of making products or process for the socio-economic development, where the policy planner or funding people can feel the difference, that unfortunately, missing. So there's a lot of responsibility, and I hope with this her project on probiotics and other things, earlier government of Pakistan has given 150 million to NIPSI for this probiotic things, and all things. I think someday they will see the commercialization by the private sector or public-private partnership. Thank you very much for giving me this opportunity.
Thank you, Dr. Yousaf Zafar. Thank you so much for this useful information. Thank you, sir.
Dr. Yousaf, we were honored to have you.